Welcome everyone. Welcome to the Illinois Greens virtual GreenBuilt home tour. My name is Katie Kaluzny. I'm the Associate Director at the Illinois Green Alliance. 2020 marks the 8th year that Illinois Green has been fortunate enough to partner with great organizations and home project teams to highlight awesome green homes throughout Illinois and Northwest Indiana. Today, we are going to focus our discussion on and home tours around deep energy home retrofits. Thank you to all of you that have joined us last week for our session on all electric homes. We're excited to continue our GreenBuilt home series today with you. But first, I'm going to talk just a little bit about the Illinois Green Alliance. The Illinois Green Alliance is a membership-driven nonprofit that works to promote green buildings and sustainable communities. We believe that green infrastructure is key to strengthening neighborhoods and improving the quality of life for everyone. To move this vision forward, the organization is committed to advancing the latest technology and design through education programs like this one, advocating for new policies, and conducting community engagement initiatives that involve thousands of volunteer hours from our green building professional community. The GreenBuilt Home Tour came about from a wonderful volunteer initiative to highlight green home best practices throughout the state through an annual tour. And we're excited to still have the opportunity to bring this education event virtually to you this year. Each date on the GreenBuilt Home Tour this year focuses on a different one of 4 themes. Last week, you heard about all electric homes. This week, we're discussing deep energy retrofits. Next Wednesday, we're talking about a passive house showcase. And then finally, on July 29th, we'll be discussing wellness and high-performing homes. We'd like to thank our partners for their help with this event. Without their help supporting us throughout the year and sharing this GreenBuilt home tour with their constituents, we wouldn't be able to have such a huge group of people on the call and on the webinar today. Thank you to the Evanston Rebuilding Warehouse, the Chicago Association of Realtors, the Green Home Institute, Passive House Alliance Chicago, Slipstream, the Citizens Utility Board, Phi Theta Kappa Honor Society of Joliet Junior College, the Home Builders Association of Greater Chicago, and special thank you for the support of the Illinois Science, Energy, and Innovation Foundation. We'd also like to thank our sponsors for their generous financial support and of the GreenBuilt Home Tour series as a whole. A huge thank you to the ComEd Energy Efficiency Program, Peoples Gas North Shore Gas Energy Efficiency Program, Brink Building Products, Mitsubishi Electric, and Insight Property Services. I'd like to give a special thanks to Brink Product Services just for their special keynote sponsor today. I'd like to turn it over to John Brooks, President of Brink Building Products, manufacturer of the Thermal Buck and Thermal Tight system, to share a few words as a key sponsor of today's program. Thank you, John.
Hello, my name is John Brooks with Brink Building Products. I'd like to thank the Illinois Green Alliance and Jamie Carr for the opportunity to talk to you. Jamie used our products, Thermal Buck and Thermal Tight, on his deep energy retrofit, and I'm here to talk to you about how he used those products in his building. The first product I'd like to talk to you today about is Thermal Buck. Thermal Buck is a mounting system for windows and doors when you use continuous insulation. Thermal Buck moves that mounting point away from your wall, so you have a flush plane to attach your cladding. Thermal Buck comes in 7 different sizes to match what you're doing on the outside of your wall. The different thicknesses of insulation, whether you're going to use a rain screen, whatever you're after, we have the solution for what you need to do. Thermal Buck simplifies this process. Typically a wood buck is used, and there's a lot of inefficiencies with a wood buck. A wood buck has thermal bridging, it's very hard to seal out moisture and water, and Thermal Buck does a great job of solving all of these issues. Thermal Buck also has an integral slope to it. It starts at 1 3/4 inches and goes to the outside edge. All the pieces have it so that your entire new rough opening is waterproof and it's made to drain to the outside. When you install your windows, you seal the back side of that for your water and air seal. Then anytime that window could possibly leak, it runs down the cavity and out to the outer face of your water barrier. Now that we've talked to you about Thermal Buck and how it will work with any type of continuous insulation, I'd like to talk to you about Thermal Tight, which is our panel system that we designed to manage the four control layers of your wall system, which are bulk water, air infiltration, thermal performance, and vapor drive. So what we started out with is an insulation called Neopor. It's a graphite enhanced EPS by BASF. So it's got an R 4.7 per inch at 75 degrees. That's a stable R value because it doesn't use any blowing agents. It uses graphite to enhance that R value. That R value increases as temperatures decrease. We laminate a high-performance weather-resistant barrier to the base Neopor panel. The WRB is larger than the panel below it, creating a flap system. The reason for that flap system is to tie the whole wall system together so that you can manage your bulk water and your air on your outside surface. We adhere these flaps with a double-sided tape. So you would first do a sideways flap, then when you come back with your next row, you have a top over bottom flap. That way any water that comes down your wall never has a reverse flap to get into your wall system. Once we have this all sealed up, then we install the windows, and then we flash the windows with our own tapes. So you have one supplier to look at to give you all the answers for your exterior wall system. Hello, my name.
Thank you again to Brink Building Products for their support today. Please shoot questions about the products in the chat and we'll make sure to answer throughout the session or during the Q&A at the end of today's session. Now we're going to be hearing a lot about home energy efficiency today and how that is measured. So we thought it would be helpful for us all to get a quick overview or refresher on home energy efficiency measurement and verification. I'd now like to turn it over to Lindsay Elton with Eco Achievers to give us a HERS Score 101 lesson that will help us all get on the same page before moving into our home tours today. Thank you, Lindsay. And I'm just going to give remote control over to you now.
Great. Hi, everyone. Thanks so much for joining us today. As you start to learn, or as we begin the presentation and you're learning about all these different homes, one of the core components of the homes and certifications, and really as a way to understand energy performance, is by getting a HERS score. And the HERS score, if my slides are working correctly, stands for Home Energy Rating System. And there we go. And so really what it is, it's an analysis of the building as a system. We're taking a look at the walls, the attic or the ceiling, the windows, and we do in the mechanicals. And then we also do performance testing, your heating and cooling mechanicals, your domestic hot water, lights, appliances, really anything that has a load. And it's all bundled up into a software. And at the end, and we go through throughout the entire construction process, and at the end, it gives us a score. And to the right here, you can see what the typical HERS score is. Our baseline of a HERS 100 is from the IECC 2006. And then you can see here what different certification programs are and where they lie. So an Energy Star home can be somewhere in the 70s. LEED certified home can be somewhere in the 50s and 60s, and it really depends on a variety of factors: solar, climate. So there's a lot to go into it, but I guess the basic understanding is it's taking it and summarizing all the different features of the home, doing performance testing, and then giving you a score. In 2019, which is the latest data, there were 241,000 homes across the US that received a score. In Illinois, we made up a little bit. We've got some room for improvement. We had 2,275 homes with an average score of HERS 60, which is actually close to what our energy code is. So we're at Illinois, we're at the 2018 IECC, which isn't on here, but this is kind of another way of understanding numerically what the slide before gave us. So so here's our HERS 100. The average existing home is around 130, so crazy. And the houses that you're going to learn today are super, super efficient. And so basically what happens is we we start off with the model. We get building plans, or if it's an existing home, we take measurements and we outline and get all of the dimensions and the specs for everything. And then during mid-construction, we're there for quality assurance and mid-construction testing. We are reviewing framing, window details, installation, giving it a grading. And then there's also optional testing that can be done, mid-construction blower door, mid-construction duct test, which we really do recommend because it gives you an understanding of how the home is performing and the air sealing measures that you're doing. You can see how that is stacking up at an early stage, and you can address issues early on prior to drywall being installed. So talk to your rater and your project team about getting that done. That is a definite helpful test to have completed. And then final testing, and me with shorter hair, is a variety of final tests. We've got the blower door over on the right-hand side, and this can be done on single-family, multi-family homes. So the blower door is your friend. It's the red door of truth, and what that does is that evaluates how tight the envelope is. The middle one we have here is our duct test. So it's kind of a similar philosophy in measuring the tightness of the ductwork. And then I'm doing ventilation testing for a bath fan for exhaust testing. So all these items are done, and we are QA'd and we get a confirmed score, and that is what is used in all of your certifications, as well as to be used if you're selling your home, and you can add the information on the Green MLS in the Green Addendum, which is this little screenshot at the bottom. If it's a new home, you can also apply for the 45L tax credit, which is a $2,000 tax credit that is usually done retroactively, but the industry is trying to get it done more proactively, but that's a definite bonus. But it's a great way to measure and assess the performance, and it allows you to make decisions for renewables if you're sizing systems, and it really helps out with the real estate aspect. So that's the HERS idea in a nutshell, and we're going to find out from all of the members today what their HERS score was. So now you have a better understanding, and Katie, I'll give it to you.
Thanks so much, Lindsay. That gives some really great context for today. I know every time you or someone explains a HERS score to me, I get a better understanding, and it's really nice to see that chart that shows you kind of where an average existing home is today versus new construction versus some of these retrofits we're going to hear about today. So thank you again. Please share your questions for Lindsay in the Q&A or the chat. She'll be back on in the program later to moderate our live Q&A with all of our presenters. So again, if you have questions for presenters throughout, please enter those in the chat. Folks that are able to will start answering your questions as we go through the presentation, and we'll save the questions that are good for everybody for the very end. So just a little bit more about today's program. Today's program features 3 unique deep home energy retrofits, all working towards affordable, practical means of achieving near net zero annual energy. Presenters will explore how achieving net zero energy on existing homes is possible across many home types and ages. The homes featured in this session are located in Chicago, Glen, Ellyn, and Arlington Heights, Illinois. Everyone has worked so hard to bring you a unique presentation about their home, so please bear with us as we transition between presenters, presentation styles, and types in our Zoom webinar. We will share this event as a recording, along with follow-up resources and links tomorrow or before the end of the week, just in case you missed anything or want to rewatch any parts of the videos. First, we're going to check out a great virtual tour from Mike Coleman with Smart House and Amy Myers and Mark Baker, homeowners of the Happy Bulow project in Arlington Heights. This historic 1967 split-level home is anticipated to be the first LEED home in Arlington Heights, Illinois, and one of the very few LEED Platinum remodels in all of Chicagoland. The homeowners look forward to the renovated home serving as a gathering place for community and an inspiration for highly functional and sustainable living. And they have an impressive HERS score of -8. So let's hear from the homeowners and the whole project team now.
We're coming to you live from the site of the Happy Bulo project at 631 North Drury Lane in Arlington Heights. I'm Amy Myers.
And I'm Mike Baker. And we're really pleased to have you join us on the tour today because it gives us an opportunity to share with you all the exciting things that have made us happy since the project began in January, all the way to its projected completion in October.
This project is much more than a house renovation to us. It's really about an intentional way of living, grounded in a philosophy that actually tells the story behind the project.
The reason we are even undertaking the Happy Bulo project and renovating our home in line with the philosophy is because we love our Drury Lane, Arlington Heights community. For several years, we had looked for a new home with just a bit more space for what we love the most, sharing homegrown and homemade food with family, friends, and neighbors. But none of the homes we saw felt quite right. Clearly, the universe was telling us to stay. Sure, it might be easier to move instead of knock down walls or live with construction for months, but it would be really hard to find another Drury Lane, a neighborhood that regularly connects, socializes, and helps each other out. So naturally, community became the first and foundational pillar of our philosophy. And here we're pursuing 3 opportunities related to community. The first, how do we create a living space that really works to bring people together and operates as a cozy retreat for the 2 of us? Secondly, how do we challenge this stereotypical experience that house project equals headache and instead have the process build community? Third, how do we renovate the home to fit into our Drury Lane neighborhood? Once we decided to stay, functionality had to become the next pillar of our philosophy. Here we're dealing with a 1964 rather constrained split-level floor plan, the type you find all over the Chicagoland area and in many other U.S. suburban areas. So the question is, how do we transform this into a renovated structure that supports living what we love and fosters healthy habits? For us, functionality includes principles such as design for ease of movement and built-in resiliency. Our third pillar, sustainability. We had already invested so much in our landscape over the years, migrating from more conventional beds to natural gardening practices grounded in the field of permaculture. So here we ask, how can we extend what we're already doing to the full footprint of the home and further enhance our outdoor practices? We are very grateful to be on track to be the first LEED home in Arlington Heights and one of just a few LEED Platinum remodeled homes in the Chicago area. We are thrilled to have such a wonderful community of experts working on the project, some of whom will walk you through how we are bringing our philosophy to life in our Happy Bulo home. I'm pleased to turn it over to Mike Coleman, our architect general contractor, the man of many hats on this project.
I'm Mike Coleman. I'm a licensed architect and owner of Smart House, a design-build company specializing in high-performance, sustainable, healthy homes. I'd like to share with you a project that we've been working on for the last year or so. Affectionately called Happy Bulo, the challenge was to take a typical 1960s split-level suburban house and convert it into a LEED Platinum and net zero energy home. How do we do it? Our approach was to try and reuse as much of the existing home as we could and design something complementary to the neighborhood, and do that all based on using the best science and technology available today. Right out of the gate, we knew we had a lot going for us because we were in an existing neighborhood and wanted to recycle the typical neighborhood home into something that could be used as a model for others to emulate.
This is a photo of the original home. Mike and Amy were interested in maintaining and strengthening a strong connection to their community, neighborhood, and street. The original front door was on the side of the house, as you can see in this photo. We realized we needed a front-facing entrance with a welcoming front porch. That required a variation from the city of Arlington Heights. Mike and Amy were very interested to try and capture as much energy and water on site to be used to power their home, as well as provide food source via site-harvested food. The site and orientation of the home provided opportunities to take advantage of solar energy in a number of ways. Here's Lisa Albrecht to talk a little bit more about the solar system design.
My name is Lisa Albrecht and I own Albrecht Solar. I've been in the solar industry here in Illinois since 2007, and I also serve on the board of directors for the Illinois Solar Energy Association. The project is going to have 27 solar panels, which should do about 110% of their annual load pre-construction. So because Mike and Amy had already lived in this house, we knew what their electric usage was in the past. It's a little bit of an unknown right now, but given that they've got a tighter envelope, even though they're adding an entire story, we still feel that this is going to do nearly the vast majority of their power usage for the next 25, 30 years. So it's been great integrating solar into such a great home design. The greenest house that you can possibly have not only includes the envelope, the energy efficiency, but also the ability to generate your own power.
In addition, by removing the attic space over the garage, we were able to create a rooftop garden and deck accessible from the back of the house and irrigated by runoff from the adjacent roof. One of the main drivers for this project was a desire to increase the functionality of the home in a number of areas. First, Mike and Amy wanted to be able to make it even easier and more inviting to share moments of breaking bread. For this, the focus was on expanding the kitchen and providing flexibility to allow for various size gatherings. One of the features we incorporated into the design is this light shaft thermal chimney. With a skylight located on the roof, light filters down through the main stairway in the house all the way down to the lower level. The skylight can be opened, natural ventilation to be drawn up through the cooler air in the lower level. The entire exterior of the home was wrapped in 1.5 inches of rigid insulation. The existing interior walls were salvaged and reused as much as possible. The exterior walls were sprayed with 1 inch of closed cell foam as an air sealer. Bats were applied over that, then drywall. The roof and attic space were insulated to R65 with a combination of bat and blow-in, and the walls achieved about an R34. The exterior of the home is designed to respect the scale and character of the original architecture. To optimize indoor air quality and comfort, we chose a conditioned energy recovery ventilation system, or CERV.
Hello, I'm Ben Newell, president of Build Equinox. Welcome to our net zero facility located in Urbana, Illinois. This is where we design and manufacture the CERV smart ventilation system. Unlike traditional ERVs, the CERV uses a small heat pump for energy recovery. This allows us to actively heat or cool and dehumidify the fresh air as it's brought into the house. The CERV is a smart system because it uses actual air quality data to make decisions on ventilating the home. Measures inside and outdoor temperature and relative humidity levels, along with independent CO2 and VOC levels. This ensures excellent air quality and saves a lot of energy.
Coupled with the CERV, we are utilizing Mitsubishi electric mini split heat pumps located strategically throughout the home. The mini split heat pumps provide the heating and cooling energy. The CERV distributes the air evenly throughout the home, and the whole system working together is a very energy efficient electric solution to all the heating and cooling needs of the home. Selecting sustainable and energy efficient fixtures and finishes is also a priority. Here's Carrie to talk a little bit about the interior design process.
Hi, I'm Carrie, design coordinator at Giuliano Design. Together with principal and owner Julie, we are designing and curating the Happy Bulo interior spaces. Interior design is more than beautiful fabrics and fixtures. A truly well-designed space functionally supports the behavioral habits of the homeowner. An added and unique aspect of the Happy Bulo design process has been the careful and deliberate consideration around the sustainability of the products and materials selected to complete the needed functionality and the desired aesthetic.
Thanks, Carrie. Now here's Mike Baker to take us a little bit deeper into the landscape design.
Thanks, Mike. Amy and I are really excited about our landscape vision because it was the catalyst that inspired the whole project from the start, and has actually evolved to manifest all three facets of our philosophy. foundation of our regenerative landscape is healthy soil, which will be full of biologically active organisms that work in concert with the soil's nutrients and minerals to impart heat, drought, frost, pest, and disease resistance to the plants we grow, without tilling chemical fertilizers, herbicides, or pesticides. We will continue to compost all garden waste and fallen leaves on site, and will coppice certain shrubs to provide renewable building materials for garden structures. The honey locust tree we took down in the front has already been milled into kitchen shelves, a fireplace mantle, and enough lumber for all the raised garden beds, as well as the wood chips that will serve as the bed's walkways. Overall, our goal is to create a landscape that uses minimal external inputs and produces no waste. Our landscape will work for us in that it's predominantly edible, and we will be expanding the diversity of herbs, vegetables, and fruits we have historically grown by adding select nut-bearing trees. The plants we choose will also be functional, whether that's comfrey used for chop and drop fertilizer or willow and hazel used for building raised bed fencing, compost bins, and plant supports. Our garage wall will provide a sunny microclimate for herbs and espaliered fruit trees, while the sun-drenched garage roof will protect other plants from rabbits. Our cold frames, raised beds, and greenhouse will extend our growing season, while the vertical structures we use in the beds and elsewhere will optimize our loaded horizontal space. The architecture of the house itself will provide the function of capturing rainwater from the roof and garage terrace and then directing it to catchment areas in different parts of the landscape. It's also important to us that any landscape be pleasing to the eye, so the plants, shrubs, and trees we choose will also provide aesthetic appeal, while their supporting structural elements will keep the landscape tidy and organized. And we also look forward to sharing our landscape's productivity with our community. We hope our landscape can be a living classroom to show what a regenerative outdoor environment looks like, along with the techniques that allow you to create such a beautiful and productive retreat.
Back on site here at 631 North Drury Lane.
Thanks so much for joining us on the tour today. And during these COVID challenging times, feel free to drive by, check out what's going on. We hope to welcome you back to an in-person tour next year. In the meantime, if you'd like more information on our project, please check us out at happybulo.com.
Thank you so much, Mike, and Amy, for sharing your incredible home story and journey. I know it's definitely an inspiration to me and hopefully many of our attendees today. Please make sure you add your questions for the architect and the homeowners of Happy Bulo into the Q&A or the chat, and we will take those on during the facilitated Q&A after all of our presenters have finished. Next up, we have our next presentation with Marcus de la Fleur. I'm going to share my presentation here. And turn over controls to Marcus while I'm giving some introduction. Our next deep energy retrofit home is brought to us by Marcus de la Fleur of De La Fleur LLC. The North Lawndale Net Zero home is a 1902 masonry 2-flat that demonstrates that even old urban dwellings can be retrofitted to make our homes healthier and more economic to run, own, and live in. The owners used a system-wide approach to turn this former energy hog into a net zero energy building targeting LEED Home for Homes Platinum. I'll turn it over to Marcus to talk us through this awesome retrofit project in Chicago. And Marcus, the controls are to you, but let me know if you need help moving slides forward.
Thank you so much, Katie. I really appreciate it. I hope my audio is okay. This is Marcus de la Fleur and Catherine Heilbach. This is our quest to make our home more affordable to live in, operate, and maintain. We are located in the North Lawndale neighborhood in Chicago and bought our building as a foreclosure back in 2009. The building actually was constructed in 1902, and our goal was to convert it from an energy hog into a net zero energy building. There we go. What did help us in our decision-making process was to look at where the energy goes in a typical United States home. And rather than focusing on some of the low-hanging fruit, such as energy-efficient lighting, we looked at where we can find the biggest bang for our buck, which turns out to be space conditioning, which can eat up to and even over 50% of your home's energy needs. To make a significant dent in space conditioning, we need to improve the entire building envelope, which includes several aspects, such as the building slab, the foundation wall, the exterior walls, doors and windows, all sorts of other holes in the walls, the attic, and the roof, of course. The improvements to the building envelope we are talking about are basically insulation and air sealing. In other words, thermal improvements to the building envelope and eliminating, eliminating air drafts, which also will make for a much more comfortable home. Let me give you a baseline from the early days of our project. One easily quantifiable metric of building is air tightness, thanks to the blower test that Lindsay mentioned at the beginning of this webinar. The blower test at the beginning of our project yielded almost 5,000 cubic feet per minute at 50 Pascal depressurization of the home. And with the help of Timothy Hepner, we sort of figured out that the cumulative area of air leaks would add up to a hole in the wall, or like a window, open window that measures 22 by 22 inches. And that window is open year round, no matter how hot or how cold. So think about the polar vortex. You're trying to keep your house warm, but you have that window that you can't close. So that's sort of what was going on there. So let me see if this moves forward. There we go. Let me ignore for a moment all the deferred maintenance items on our 100-plus-year-old home that we had to uncover and fix. In order to tighten up and insulate the building envelope, we had to get to and basically find all real and potential air leaks, which basically means cutting the building down to the masonry walls and the studs and start over. And in that process, we salvaged as much materials as possible. We had a construction waste management plan, and what we couldn't salvage was sorted for recycling, which left us only with a small amount of debris that went to the landfill, such as the old plaster. Back to the building envelope improvements, we used what's called a flash and bed strategy that was tailored to our building. We basically started off with an uninterrupted layer of closed-cell foam across all exterior walls for air sealing, followed by a layer of open cell foam and rock wool beds, which in the end yielded an insulation value or R value between 28 and 40. Now, I highly recommend to tailor any air sealing and insulation strategies to the specifics of your building and your energy goals, as every building is really different, in particular existing and older buildings. Now, that takes care of the walls, except that we still have those pesky holes that are left. Some people call them windows. This is a tricky subject, as it is hard to make money back on expensive and high-performing windows. Here are a couple of aspects that I can share. Whatever window you pick, they really should somewhat correspond to your insulation assembly. In other words, there's no point in having really good insulated walls and then you have lousy windows, or the other way around, you have really high-performing windows, but the insulation in your walls could really be better. In this day and age, there's really no reason to pick a window that has a U factor greater than 0.2. These well-insulated windows are now widely available for a very reasonable price. Also, the more moving parts on the window, the greater the potential for air leakage, which brings me to this blank field on this NFRC label. What should be listed here is the air leakage for this window. If it isn't listed, make sure to ask what the air leakage rating is. Now, even though Energy Star is requiring an air leakage value of equal or less of 0.3 cubic feet per minute per square foot area of window, that 0.3 value would be a rather drafty and uncomfortable window. So I definitely recommend that for a comfortable window or something that's somewhat airtight, one would need to drop that value by an order of magnitude to something closer to 0.02. Now that we have tightened up the building envelope, it's time to get the blower test up and running again, and our results dropped from the previous 5,000 cubic feet per minute at 50 Pascal down to 400 cubic feet per minute. Or in other words, use the hole in the wall analogy again. We went from a 22 by 22 inch hole in the wall down to a 6.5 by 6.5 hole inch in the wall. Now that is one big problem solved. Problem is another one is created. With natural ventilation basically eliminated and now flushing out of pollutants, we now have to address indoor air quality. In other words, how to prevent the indoors from feeling smelly and stale after a few hours or days. And depending on what feed you feed these guys, make it stay within minutes. Maybe that's TMI. However, moving on, to provide healthy and energy efficient levels of fresh air supply, we employed an ERV for each unit in the building, which is basically a ventilation unit with a built-in heat exchanger. The ERV has one side that connects to the exterior of the building, and if we turn it around or flip it around to the other side, we look at the side that connects to the interior of the building, and we have an enthalpy wheel that sits between the two sides, which you can see in the background there partially. That enthalpy wheel transfers sensible and latent energy between the air streams. In other words, it transfers thermal energy and moisture content. Now, what I should clarify is that it's not the wheel, but the filter piles in the wheel that are responsible for the sensible and latent transfer. The fresh air supplies within the ductwork and the layout, the fresh air supplies go into the bedrooms and are distributed among other rooms to provide good airflow, while the exhausts go into two wet rooms, i.e. the two bathrooms. This way we can assure a good and healthy indoor air quality while minimizing, this is really important, minimizing energy penalties thanks to the heat exchanger in the ERV. I have to say, I really love this gadget. I love the ERV, particularly in the wintertime. It is like having a window open all the time to get fresh air in, but it doesn't get cold. I absolutely love it. With the peak heating load on our project estimated and reduced, and that includes domestic hot water, reduced to 37,500 BTU, we were able to install a small hydronic heating system with an indirect fired domestic hot water storage tank. The air tightness in combination with the insulation strategy does show in the energy consumption when we look at the space heating, where we recorded an 80% reduction in 2016. Now, since then, this primary heating system has been demoted to a backup heating system with the installation of our all-electric mini splits or air source heat pumps, which provide us with the needed winter heating and summer cooling and dehumidification. With a significant reduction in the overall electricity demand, we were able to add a grid-tied photovoltaic system, or photovoltaic array, also by Lisa Albrecht, that basically powers all our electrical needs, including the mini splits, including the heating and cooling. Now, this last step was the one that puts net zero energy within our reach. But what we have to remember, it only did so because of the building envelope improvements, of the air tightness, and of the overall energy reduction. All these had to come first. To conclude, we reached our goal of a healthy and very comfortable home that is affordable to run, operate, and maintain. And of course, there are many aspects, small and big, that are not mentioned here, such as our community or a sustainable landscape that is still in the making. But maybe I get a chance to talk about those aspects at next year's Green Building Home Tour. That is all from us, and thank you so much, everybody. Down below, there is a link to our blog that basically documents the entire process of the deep energy retrofit, where you find a whole lot more information. Thank you so much, everybody.
Thank you so much, Marcus. It's a great presentation. I know I've talked to you about this project over many years, so it's really cool to see all of it in action and happening. I also have some of those pesky holes called windows that give me a very hard time in my 1930s bungalow, so I appreciated the tips and something that I'll have to tackle in my house eventually. So thank you so much again. Please be sure to share your questions for Marcus in the Q&A or in the chat, and we will get back to you there or during the facilitated Q&A. Next up, we have a final stop on our virtual tour with Jamie Carr of EcoAchievers through his home retrofit in Glen, Ellyn. Jamie will explain the vision of the Glen Ellyn Deep Energy Retrofit to take an existing 1961 ranch home in a great location and completely transform it into a home that was beautiful yet practical at near net zero energy use, yet comfortable year-round, healthy, and yet reasonably affordable. The house is all electric and uses no gas. Let's check out Jamie's virtual tour now.
Hi, my name is Jamie Carr. I'm a partner at EcoAchievers, and this is a tour of my personal home in Glen, Ellyn. When we bought the house, it looked identical to the one next door. The kitchen hadn't been updated since the previous owner moved in 1963. Now it's an all-electric, nearly net zero home. The HERS report shows an estimated annual utility cost of $86. The 10 kilowatt 31-panel solar array, designed and installed by Lisa Albrecht at Albright Solar, provides almost all of the house's power. Tom Bassett-Dilley and another architect in his office, Denny Burke, were the architects for this project. They are excellent with high-performance building concepts and details. They did a great job making this house work on the existing foundation, which can be really tricky. Here we're seeing mostly native landscaping that just went in last week. I took a sabbatical from EcoAchievers and acted as the general contractor on this job. During demo, we separated all of the metal so it could be recycled. And we did the same with the brick from the chimney, which you see being used here as edging to divert water away from the house. My helper and I also took down the roof piece by piece and saved it to be reclaimed in the house. Before we started framing the house, it looked like this. I cleaned down all of the wood rafters and ceiling joists. And they became the built-ins you see here and throughout the house. Kids use this area as a drop zone for their various projects. One of the visual aspects of the reclaimed wood that I really like is how you can see all of the nail holes. While the video walks us through the house, I want to talk about what I see as 4 keys to green building in our climate: a good envelope, good indoor air quality, conscientiousness about water quality and use, and good mechanicals. First, let me orient you a little bit. We just walked through the living room, dining room. This is the kitchen. Not all of the cabinet fronts are on yet. Kitchen then connects out onto the screened-in porch. The porch faces west and provides shade to the kitchen in the afternoon, but also allows a view from the house out into the park beyond. By a good envelope, I mean a well-insulated, thermally bridge-free walls, an airtight building assembly, really good windows. In the video, you can see the windows here in a moment, which are Alpine, European-style tilt-turn windows. In the picture on the left, if you look carefully, you can see thermal bucks around the windows. Thermal bucks consist of rigid insulation encased in a polymer coating which surround the rough opening. The exterior insulation, something I believe is really important for all high-performance homes, comes up to meet these thermal bucks, providing a completely thermally bridge-free assembly. One of the things I love about the house are these high windows and this open to above space in the kitchen. I think Tom and Danny also did a great job designing this apparatus on the ceiling that connects the dining room and the kitchen and provides a home for the task lighting above the island. As we go into Sarah's office and then the guest room / away room and the downstairs bathroom, I want to talk a little bit about indoor air quality. Indoor air quality, like air sealing, is one of those things it's hard to get right because so many different trades are involved. And it requires constant and meticulous oversight from the general contractor. In this job, I bought every sealant, every glue, every paint, every finish, and checked each one to make sure it was third-party certified for indoor air quality. Ensuring good indoor air quality can quickly get complex, but looking for the Green Guard label is a good start in vetting products for indoor air quality. In addition to air quality, we also thought about water quality and conservation. The water-using appliances like the clothes washer you see here are all Energy Star labeled, which ensures minimal water usage. Likewise, the faucets, shower heads, and toilets are all EPA WaterSense rated fixtures. And in the basement, we have a whole house water filtration system, which you see at the left, that ensures high quality, healthy water throughout the house. As we walk upstairs, I'll show a few quick shots of the construction of the stair and talk a bit about our decision to build up rather than out. Mostly we did this because it was less expensive, But as an added bonus, we preserved the large backyard that opens onto the park. Adding the stair was the only modification to the existing 1,000 square foot footprint of the house. Upstairs, there are 3 bedrooms, my office, which is beyond the transom windows you see there, and a bathroom clustered around this central open area. The central open area is another one of my favorite spots. I love the light that the high windows bring in, and the sense of openness provided by the cathedral ceiling. Working with Tom and Denny, we made the very conscious choice to keep the bedrooms small and have just 1 bathroom upstairs, so we could make the most of this space. Our goal was to create spaces, including this one, that got used and enjoyed every day. Framing the house this way was extremely difficult, but it presented the opportunity to create significant architectural interest. I'm a big believer that what makes things beautiful and what makes things sustainable doesn't happen on the surface, because that's not what creates comfort. Comfort happens because of quality design and execution. I believe that creating a house that's beautiful and highly functional is just as important to sustainability as energy efficiency or indoor air quality, because it means the house will be used and cared for long into the future. So we walk into the bathroom here in a moment. I'll mention one other green feature of the house that marries design and sustainability to create comfort. When someone walks into the bathroom, a motion sensor turns on a very efficient pump that feeds hot water to all the piping. When you turn on the faucet or shower, you get hot water right away. This both saves water and energy, which promotes efficiency, and also is much more comfortable because you never have to stand waiting for water. We're now going to tour the master bedroom, which we'll see here, then my office and the kids' bedroom, and then we'll head down to the basement. As we're doing this, I'm going to take a few minutes to talk about the house's mechanical system. The house's mechanical system is key to all of what we've discussed so far, including especially comfort, energy efficiency, and indoor air quality. Because the house is so tight, it needs a source of fresh air. So this unit on the left, located immediately above where I'm standing now, a Renewables EV200, provides continuous fresh air to the house. The supply air is provided high on the wall in this central open area, so it can fully mix with room air before coming in contact with people. ERVs use very little energy to supply ventilation air, recover energy from room temperature before it's exhausted, and significantly improve indoor air quality. These 2 heat pumps provide all of the heating, cooling, and hot water for the house. The unit on the left is a Sandon air-to-water source heat pump, which provides all of the domestic hot water and a significant portion of the heating for radiant floor heating on the first floor. The unit on the right, in the previous slide, is a Unico I-Series cold climate air-to-air source heat pump. It provides the remainder of the heat the house needs, as well as cooling in the summer. There is no gas line to the house anymore, and no gas used anywhere in the house. Here, you can see the high supply for the ERV I mentioned earlier. Not having combustion in the house not only improves indoor air quality, but it means the house can be powered entirely by renewable sources. Metal roofs are a great fit for solar because the racking can clip right onto the standing seams, so there's just one penetration through the roof for power. As we go down to the basement, we're passing through the back entry of the house, which is at grade and features the same reclaimed wood, shelving and paneling we saw earlier by the front entrance. I think Tom and Denny did a great job here as well, making this space both really functional and beautiful. In the basement, there are several things I'd like to point out. The first is how we saved all of the existing first floor joists and subflooring. They were all in good shape, so before we started framing, we put down a new layer of plywood subfloor to stiffen everything up and make sure we started with a square and level base. Next, I want to show the oversized hot water storage tank, the heat exchanger and pump for the radiant system, and the radiant manifold. I chose the Sandon system for hot water and radiant floor heating for a few reasons. First, because it's super efficient. Second, because it's a split system heat pump, meaning it captures heat from outside rather than inside. Finally, the Sandon uses CO2 as a refrigerant, which has a global warming potential over 2,000 times less than standard refrigerant. Finally, I wanted to point out the solar inverter on the wall here. This is the only piece of solar equipment in the house, which makes solar a good fit for both retrofit and new construction applications, especially given current incentives and pricing. In our final few moments as we walk through the backyard, I want to share a few closing thoughts. First, deep energy retrofits can be amazing, but they are not for the faint of heart. They're amazing from a sustainability perspective because they preserve all of the embodied energy of the existing building, but they involve a lot of work and uncertainty. Second, if you're thinking about doing something like this yourself, make sure you surround yourself with a good architect and MEP consultant, a good general contractor, and a good third-party green rater. I learned a ton in the process of building this house, including some things I would do differently, and I hope I have the opportunity to share more about some of those lessons learned with some of you. Thanks so much for your time. I hope you enjoyed the tour.
Thank you so much, Jamie, for the awesome presentation and virtual tour. I loved how you were able to pair the video with the slides and kind of walk through the process. I felt like I was on the actual GreenBuilt home tour and viewing your house. So thank you so much again for being able to participate in this way and share such a great video. I am going to pull up the next slide, but I want to thank Jamie again and also put your questions for Jamie and the rest of the crew in the Q&A so that we can address those shortly, just after our next presentation. I'd now like to introduce you to one of Illinois Green's awesome volunteers, Scott Taransky. Scott is a volunteer in our Climate Action Ambassador program. Our Action Ambassadors were trained earlier this year on great actions you can take at your home and in your own community and how to share those within their community. Unfortunately, we have not been able to do a lot of sharing over the last few months in the way we had intended. So we're really excited to have our Climate Action Ambassadors participate in each of our GreenBuilt Home Tour series to share some tips about steps you might be able to take in your own home to start your journey to explore energy efficiency retrofit opportunities similar to the ones you've heard today. So I'm going to turn it over to Scott and he's going to get started in sharing some tips. Take it away, Scott.
Thank you very much for that introduction. My name is Scott Taransky. I am a Climate Action Ambassador, like she said, and we work with Project Drawdown to reduce greenhouse gases and wasted energy. My background, I don't have a home building background. I went to school for engineering, although my senior design project, we worked on LEED certified houses. So sustainability has always been a passion of mine. Often in my job, I look at processes and we got to optimize them. When you're optimizing a process, I would say there's 3 ways to improve a process. You can have better inputs, you can have better processes that are more efficient, and you can have less waste. Obviously, more of these is better. It leads to more efficiency. 2 is better than 1, and 3 is ideal. What I'm going to talk about today is 2 ways that you can improve your home. They do at least 2 if not 3 of these things, better input, better process, and less waste. First, we're going to start with the heat pump. These were a bit complex, and I'm sorry for the small image, but if you Google how a heat pump works, it's very worthwhile. What ends up happening with a heat pump during the winter time, the cold air outside, even though it's really, really cold, that air is actually warmer than the refrigerant in the heat pump. And so by the laws of thermodynamics, that cold air outside heats that refrigerant, warming it. It then at the top of the image, you can see there's a compressor. And if you've been at home because of COVID, you might be cooking a lot more, and maybe you've been using the Instant Pot. Same principles apply. Pressure's applied, and that raises the temperature. And you can see it comes out of that compressor into the home. That heat is released into the home. The refrigerant drops in temperature, and then it goes back outside, and the whole process goes again. So it's pumping, rather than burning a flame, it's taking that air, transferring the heat. There was a question, how does the heating and cooling work on some of these homes? All 3 of the homes that we just saw had a heat pump mentioned at one point. What's cool is on some of these, you can switch the direction. So it does the same thing. Now it goes in the opposite direction. So the heat from your home transfers to the refrigerant. And so the refrigerant draws more heat from your home because it lowers the temperature. There's a valve at the bottom, and then that heat is expelled to the outside air. So very, very cool processes. Definitely take a look at these. Looking at the things that I mentioned earlier, they use the outside air instead of burning coal or natural gas. There's a better process. There's no burning of anything. There's no transportation of fuel that's needed. These are 2 to 5 times more efficient than a furnace, which is awesome. You can also combine it with solar because this heat pump oftentimes is electrical. So that's a way where you can have a bigger impact. When I did a simple Google search on heat pumps, they came in anywhere $2,000 to $3,000. Your mileage may vary, but I did see on ComEd, there's also a rebate for these, can be up to maybe $500. So I'm curious to see the 3 houses that we just saw, maybe theirs were in a similar range. But it gives you a ballpark when we're looking at this, what you can find out. So a lot of really cool things on these heat pumps and definitely worth checking out. So now let's move into water savings. And being honest, when I used to look at sustainability things, and because you can't do everything, it's always like, okay, well, I'm going to focus on energy efficiency and greenhouse gas. Yeah, we should save water, but it wasn't as apparent why. One of the reasons, besides obviously just saving the water, is that it takes a lot of energy to process water, to transport clean, drinkable water to your home. And that same water is used for everything, whether it's the toilet, the sink, your drinking water, the garden, all of those aspects use the same water. So the more of that water you use, the more energy that's required to purify, transport the water to your home. So if we use less, that's a simple savings that has a big impact. That's why this is one of the drawdown strategies. So there's a lot of different ways where you can save water in your home. Jamie, our last presenter, mentioned a lot of these. He said, okay, this is heating up the water last minute, but it's not, you don't have a big tank that's full of hot water, wasted energy. Some other ways to reduce water usage. Rain barrels. I have a couple friends who actually have these. They sit in their backyard. They're a big 55-gallon drum, and they're about $45 from the city. They are great for watering your flowers. In fact, apparently online people say that the flowers prefer that water than your hose water. Washing the car, washing the dog, anything basically that you're using the water for, they have a little spout at the bottom and they're used to just water, and you collect the rain. They have a mesh on the top and all the rain comes in so no bugs or anything gets in. It's really cool. Like I said, they're about $45 from the city, and depending on where you are in Cook County, your water bill is $3 to $10 per 1,000 gallons. So you can see if you're in like Elk Grove Village, that's close to $10 for 1,000 gallons, that they get used really, really quickly. Additionally, look at low flow fixtures so that you're using less water every single time. I'm sure you've seen it in different facilities where toilets have dual level flush, where it uses less. You can choose which option to use, so you're using less of the water. On top of that, there's things that you can do around your home that help reduce water even if you're not having the hose on. For example, mulching reduces water evaporation. Water in the morning and evening, it reduces the wasted water that's coming out of the hose. So if you just using the right timing, it uses less water, which saves us energy. So again, water, better inputs, it's using the rainwater from the barrels. You have better process because we're not transporting as much water. There's less purification energy that's needed. And you have less waste, both in terms of water and electricity. So those are some things that you can apply simply to your home. If you don't have the renovation budget to do a full reno, you can do small steps that make a big difference. Katie, I'm going to pass it back to you.
Thanks so much, Scott, for all of those great resources and tips. We'll be sharing all of these tips with you in the follow-up email that you'll get from this webinar, and you'll be able to click all of those links that were in Scott's slides. And thank you again, Scott, for being a climate ambassador and sharing these tips with everybody. I know everyone wants to think of the first thing they can do to get started after checking out a session like this. So it's great to have those resources. I'm going to stop sharing now and finally make it to our Q&A. Thank you for sharing all of your questions with us throughout the presentations. I'd like to bring Lindsay Elton with EcoAchievers back to help us facilitate the Q&A, and all of our panelists that you have not been able to see this whole time are going to show their faces so you can see all of their answers to their questions. So welcome back, Mike, Amy, Denny, Scott, Jamie, Marcus, and Lindsay. Take it away.
Cool, thanks. So, wow, it's been blowing up out here. So thank you all for participating and being active in your questions and the conversation. Since I'm kind of emceeing this, I'm gonna take one of my personal questions for y'all. And just in case you didn't mention it at the beginning, if each of you, and I can call your name first, but if you could just say what your HERS score was again, just that everybody knows, if you had your HERS score done or your projected score. Again, the existing home is a HERS 130, baseline is about 100. Code right now is somewhere in Illinois about like 55. So I'll start, Marcus. What did your HERS scores range from? And you're on mute, Marcus.
There we go. Sorry, I don't have a HERS rating yet. We still need to go through the whole testing process.
Okay. All right. Mike and Amy?
Yeah, so we are projected for a HERS -8.
Awesome. Jamie?
I think it's a HERS 4.
HERS 4. So, and a little spoiler, we did HERS ratings for Marcus, and his home or his scores came in super low as well. So so all of these homes with their insulation and air sealing and different HVAC strategies all came in super efficient. So so another one for I think that came up across the board is the question of costs, and you don't have to, for all of our panelists, maybe not an exact number, but talk about kind of either if you can give a general range, square footage, or what your budget or goal process was. And I will, Jamie, I'll let you start.
I was hoping I was going to be third, so I had some time to think about that one. You know, I don't know that I want to share the exact cost, because I don't think that that's representative of what it would cost someone else to do it. You know, I acted as the general contractor, so there wasn't a general contracting fee. I was also very, I think Marcus said something about pinching every penny. I mean, I made it go far. That said, you know, this house ended up being more expensive than a typical house in our neighborhood. But you know, it's very different. It has better windows and better, you know, if you think about everything being, you know, just a little bit better, all of that little bit better adds up cost-wise. Yeah, I mean, Denny might be able to speak more generally about sort of typical prices they see for, or ranges that they see for their typical projects.
Sure. Denny, do you think you can speak to that?
Yeah, I mean, I can speak a little bit. So we see quite a range. I mean, and it does depend on whether it's renovation or new, and the finishes and such play a part into that. But we see a range from anywhere from 250 to kind of 350 square foot, depending on everything that's going into it. So I mean, pretty broad brush, but there's a lot of different factors that go in.
Sure, thank you. Marcus?
Yes, I posted in the chat that we had budgeted $160,000 for the deep energy retrofit in our building. That is 3 units. We have a 2-flat, so first floor unit, second floor unit, and we had additional living unit permitted in the basement. And I think we are sort of pretty close to it. But I have to caution the same way as Jamie did. Every project is really different there. The question is what is included in this and what is not, particularly if you have an existing old building like we have. So, at one point we have to replace the roof. At one point we have to replace the back porch. So is this part of the deep energy retrofit budget, or is this just, maintenance that you have on the house that you have as long as you own the house? So it gets a little bit fuzzy there, but when we did the initial math and tried to figure things out, we budgeted $160,000. But again, like Jamie explained, I was GC, acted as my own GC. I did quite a little bit of the work myself. So we were able to save quite a little bit here and there, and thus keep it at $160,000. I don't want necessarily raise expectation that, $160,000 is easy to do. No, you have to work on it.
Right. And Mike and Amy?
Yeah, so for us, our project's a bit different just because we actually, if you go to our website, you'll see we actually consulted with a financial planner. That's kind of what sort of kicked off this whole thing for us was, what do we do with the money that we had saved? And we don't have children. We like the community so much that we essentially have spent the kind of money that ensures we will be here for another 20 to 25 years, if not longer. And really, when we're not remodeling the home to sell it in 3 to 5 years. So we're really not looking at resale value. We're looking at trying to build a home that fits our way of living, while at the same time, when we are at a point when we do have to move out, in our 80s or whatever, that the house is actually current. The house is actually contemporary with what people expect. When they go type in Google, whatever that is in 25 years, they type in what to expect in a new home when they purchase a home. So we've tried to anticipate what those search results would be on Google. And so the budget for this, yeah, I'll be honest, it exceeded what we originally planned on, because as we go through this, it's an iterative process. We didn't know what we wanted originally. We ended up with a new front porch that was not part of the original budget. You ended up with a lot of other things that we didn't plan on, not because not because we've been, had the wool pulled over our eyes, just because we realized there's things that we wanted. So kind of starting at that baseline, 175, 200, square foot, cost per square foot. And I know that ranges, that varies. And so that's kind of the ballpark for us. But a lot of our project involves things that go beyond sort of the deep energy retrofit. So like Marcus said, is this part of the deep energy retrofit budget, or is this part of like maintenance? For us, adding on a master suite upstairs has nothing to do with, sustainability as much as it does. We both work from home, especially Amy, and we wanted a place that was conducive to that. We also wanted a place that allows us to actually engage with the community in a much deeper manner than the house was allowing us to do before. And the design really, it's holistic, and I know that that sustainability is just one facet of our project. And no one of the 3 facets of the project dominate the other. That's the other important thing about ours is, the community aspect is just as important as the sustainability. And, to be honest, when you're living in a suburban context, there are trade-offs, right? And so I would love to do a lot of the things that I'm just raring to go and do a lot of, change things, change ordinances, but it's not realistic to do that. Can't snap my fingers and make that happen. So I think for us, it's the cost involved for us. Actually, we got clear on that years ago, that for us, this is our child. If you go Google up how much it costs to raise a child from birth until they're out on their own, that should give you a good idea of the budget that we're talking about.
Good. Cool. Thanks, Mike. And so with that, I'm going to go to our other Mike on the project. And if you could answer one of the questions, what are some of the challenges that you faced doing a deep energy retrofit? How does that differ from a new construction project?
Well, thanks. Yeah, you have to make a lot of decisions on the front end in terms of how much you're going to reuse and recycle, repurpose. That's a challenge as compared to new construction where you've kind of got a blank slate. So our philosophy, our approach has been to try and reuse, recycle, repurpose as much as possible. And we started out thinking about that and how can we do that? So that makes it a little bit different than a typical new construction project. And then, getting deeper into it, how do you accomplish all those goals that Mike was just talking about? How do you make it, a lifestyle type project? How do you increase all the efficiencies, in a cost-effective way? So every element of the project has to be analyzed in terms of its sustainability, in terms of its life cycle cost, in terms of, all the trade-offs that, may be involved in picking one product over another. And then you have to balance that in the long run, just like you would on even a new construction project with, what's the payoff, what's the long-term life cycle cost of all these different choices you're going to make, and come up with the best solution that fits in with an overall concept, a budget, and that's challenging. So, I guess the more difficult thing about remodeling a home is you really never know what you're going to find until you start opening up the walls. And that can always add some surprises, which could result in decisions and costs as you go. You can't see through the walls when you start. You can't see through, all the structure. You use your best intuition as to what you're going to find. But there's going to be some surprises. And you really have to build in a little of that, in your process so that you can react to it in a timely fashion, have the funds to deal with it, and make good decisions.
Okay, great.
Lindsay, just to jump in really quick, to echo all those points, we similarly can find that for a rehab project, you can easily get, well, not easily, but you can definitely get, sub 200 per square foot costs. But as Mike said, it's you have to look at everything kind of in a real life feedback, because you never know what you're going to run into when you do start peeling back the layers of the onion. It's having that bit of a contingency or, willingness to move with what has to, takes the right person to kind of be okay with that level of uncertainty as you get going.
And maybe this can go to, since a lot of you we're obviously are working with retrofits and we're reusing materials. How did you determine what to reuse and what to replace? Jamie, we can, if you want to.
Yeah, I just want to finish up, sort of piggyback on what Mike and Denny just said, and then answer that question, which is that the other challenge I found to a retrofit is sort of marrying the new component onto the existing component. So in this case, we added a stair, getting that elevation just right, and getting, it's trickier than if you get to start with an elevation that's all the same. So it takes more thinking and more decision making through the build process than sort of typical ground up new construction does. As for what to reuse, I'll do that in two ways. So first, I knew that I wanted this to be a rehab for code purposes, because there are advantages to calling something a rehab versus not calling it a rehab. And so we worked with the building department to get sort of as close to that line as we could without crossing over it, because we knew we wanted to do like a really deep retrofit. And then as we were getting into it, it was like the wood was sort of just found in a way. Like I started demoing and I was like, I looked up and I was like, this is really beautiful. We should do something with this. Though I think, like Marcus was saying earlier, one of the things I learned through this process is that money and time are sort of interchangeable in a way. So that material wasn't very expensive. It was all here, it was all found. The amount of time that I and my helper, who I paid to help me, invested in getting that wood usable, it cost just as much as if we went out and bought the wood. So it's not like found materials are free, because the amount of labor to do it costs money.
Cool. And maybe Marcus, I see you smiling over there. Maybe you can add a little on to this.
Yes. So what did we reuse? So we bought this over 100-year-old building. So there were quite a few treasures in here. But just going back to the wood component that Jamie mentioned, we had a beautiful quarter sawn oak trim all over the house under at least 1/8 of an inch of paint, layers and layers of paint. And same as Jamie, it's that balance. Could I have gone out and bought it for the amount of time and money I spent in cleaning it up? Actually, no, because you can't buy that quality of wood anymore. So for us, it was a no-brainer. I could have bought something for that price, but it would not have been the same other quality. So this 100-year-old wood was just absolutely priceless. Same for the hardwood floors. We were able to salvage those. So in an old Chicago building, whether it's a gray stone or half gray stone like we are, there are all sorts of interesting treasures you find that you definitely want to salvage and reuse.
Cool. So there were a handful of questions regarding mechanical systems and kind of clarifying. And Jamie, I saw that you had answered, and Marcus, I'd just like to see if you all could just kind of give a brief summary. We know that heat pumps were used, but give a brief summary of kind of the unique points of what your mechanical systems were or are, if there are any unique points. Mike, I'll start. Mike Coleman, I'll start with you.
Okay. We chose the Mitsubishi mini split heat pumps for the heating and cooling energy. And then we used that serve system manufactured in Urbana, Champaign, Illinois, which is really a smart ventilation system. It has a brain built into it, so it senses all these different factors, environmental factors within the home, and really strives to give you the highest indoor air quality possible. That is a ducted portion of the system. So the mini splits are ductless. The serve has a small duct system that is run throughout the house that is constantly on. It's continuously moving air at a very low velocity. I think it's like 200 CFM. It has MERV 13 filters built into it. It has a little mini heat pump built into it. So as the outdoor air is coming in, for example, in the wintertime when it needs fresh air, it's boosting that to a temperature that is compatible with the indoor temperature of the home, so you don't get a blast of cold air. And same thing on exhaust. It's checking air quality, and if your exhaust air doesn't require to be put outside because of the temperature or humidity level, it'll recirculate it through the filtration system into the house. So it's like Marcus said, it's really like opening your windows any time of the year. It's telling you the best way to do that and the right time to do that. When that fresh air is needed, it brings it in. So this is really a high-tech component to our HVAC system, which I think is fantastic. The other component really would be the hot water heating. We used on-demand heating for that. It is gas. It's the one gas component we do enter. They did have gas service coming to the house originally, so we maintained that. But again, that is for the hot water heat only. Other than that, everything is going to be electric and very efficient, so and very healthy.
Yeah, yeah. The Serve is a pretty cool system. The interface is really neat as well. And Celeste, I know that you had sent a note out in the chat about how it relates with COVID. And thanks to Tom and some other folks for responding back to that about just checking out the Build Equinox website. And they've got a lot of information out there. Thanks, Mike. Jamie, I'll move to you.
I think the unique point about my mechanical system is probably the Sandin unit, which I talked about some in the video. You know, it's probably not for everyone. It's quite expensive, and I mean, I'll be honest that through my sort of industry connections, I got, you know, is how I ended up with it. So I think that piece of it is unique. The other piece is, you know, I've seen a bunch of really low energy houses now, and I don't know about Mike or Marcus's house specifically, but I would warn people watching this that even though the house has a really low load, doesn't mean that just one or two mini splits is going to be able to create comfort through the whole home. I feel like early on in this sort of low energy movement, people thought that that was possible, and I think that over time we realized that short ducted systems with mini splits can be a really good way to go. I'm not saying, you know, well-designed mini splits work. It's just something you need to be careful with and think through really carefully.
Thanks, Jamie. Marcus?
What's unique about our system, I think the one word I can use is redundancies. You have noticed that we started off with a hydronic heating system, in other words, hot water radiators, and then we switched to mini splits. And there's a sort of a thought behind it. First of all, you know, if one or the other system goes down, which actually has happened this last winter, then I have the other system to back it up, which is really nice. The other component or the other decision that, or effect that led to this decision is that when we started this project 10 years ago, there were systems out there and there were systems that were not available. We looked to Europe. There were lots of systems there that I would have loved to use, not available in the United States yet. So you have to take this wait and see approach, and that's what we did. I think the hydronic heating system in the end will pay off because I expect more development in the solar hot water to come along the years. 10 years ago, solar hot water was still a hot thing to do. And then suddenly with photovoltaic getting cheap, solar hot water sort of fell off the wagon completely. But you know, there's research going on right now that may bring solar hot water back. And if it comes back, I'm ready. I have the system down there. All I need to disconnect the natural gas and tap into solar hot water. I'm up and running again. And then I have, again, the opportunity to toggle between, you know, the radiators or the mini splits, depending on what level of comfort I need at what temperatures outside. Like Jamie said, the mini splits are very efficient, but unless you have an open floor plan across your building, it can get hard to get equal temperatures across all rooms. You have to expect that the end of the house is 2 degrees hotter or cooler than where the mini split is located. And if you can live with that, fine. If you cannot, then you may want to look into design and work around this a little bit. But again, the one key aspect that makes our system unique is the redundancy factor, I would say.
Awesome. Thanks, Marcus. I'm going to take a step off from building science and talk about how your homes and your process interact with your community and kind of like the educational piece. So Mike and Amy, I'm going to give this one to you first, but could you tell us what your process has been in your interaction with the community, your neighbors, officials, letting them know about your house and kind of what's going on and just how you've done with, you know, what your story is.
Sure,
Well,
happy to. Yeah, so yeah, I must admit that's one of my favorite parts of this project. So basically, big reason, as I said in our presentation, that we stayed was because we absolutely adore Drury Lane. And we just love the cohesiveness of our neighbors. And quite frankly, if we think about something we're all faced with right now, to some degree, is we're kind of at home and we're not connecting as much, or maybe we're mostly connecting online. So I'm sure everyone's feeling a bit that desire to connect with other humans. And so we recognized early on that it was going to be critical that we design a home that is going to fit into the neighborhood, that our neighbors are going to be happy with. They're going to be proud that it's a part of this Drury Lane cohesive neighborhood that we have. And so early on in the design plans, we enrolled our neighbors. We shared plans with them over some homemade food, which we love to make. So particularly some good cakes and tea and that kind of thing. And all the people right around us gave us input on our plans. That was really important to us. We also went in front of a couple of the commissions here in Arlington Heights. One, the design commission, to make sure the overall architecture was going to fit, and that went quite well. And I think thanks to that design commission for giving us some additional input, so we leveraged their input, we welcomed it, and yeah, we were kind of given a thumbs up. But they appreciated the fact that we were very sensitive to how it looked and how it would work itself into the neighborhood. And then we also went in front of our zoning board of appeals to basically get allowance for going beyond the average setback to have a porch, which was all about, of course, having a more welcoming home for great neighbors like those living on Drury Lane. So that was part of our neighbor enrollment, our town enrollment. We also had a project kickoff involving friends, family, and neighbors. And throughout the project, we've also enrolled all the people on the project into our vision. So this is not like a headache of a project. So everyone's having a good time, knows why they're up to this important work, knows what we're hoping to do. And we're really looking forward to a big dinner with everyone, down to the subcontractor of subcontractors in our home who've contributed to Happy Bulo at the end of the process. So the whole community aspect to me is key, because we live in neighborhoods, we live in communities. Let's make the most of those, and let's let our homes enrich the communities we live in.
That's really
What
awesome.
she said.
Just what she said. Yeah, that's incredible. And when you break bread with your contractors, that's a whole level, different level in your community of interaction and togetherness. We've got 2 minutes left. Jamie, I'm gonna give you the next minute, and then Marcus, you can close us out.
Well, I'll just say that one of the joys for me of being a general contractor was that I was here a lot as it was getting built. And so I sort of saw neighbor relations as one of my roles on the construction site. And it was a lovely way to sort of move into the neighborhood, they were all curious what was going on. And, you know, once I get going about building science, I can talk for a while. So it was really lovely to sort of get to know the neighborhood through building the house.
Cool. Marcus?
Yes, so neighborhood connections. It was interesting. We bought the house, and in the North London neighborhood, initially nobody believed we would live here. They all were convinced that we would fix it up, flip it, and run. And after 3 years, it finally thinking, well, these guys are here to stay. And I used local resources, you know, carrying things out, putting things back together. And it's always sort of an interesting process, because you hear nothing forever. And then about 3 or 4 years, and suddenly you realize what actually has sunk into the community when you start talking to folks that stop by, etc. And then you're also surprised that, oh, so the thing you talked about Windows 2 years ago, that actually stuck. It's really interesting. And it's similar to what Amy and Mike are doing in planning. We had open houses, etc., inviting people in. I love being on the GreenBuilt home tour, spreading the word that way. That's a broader community than just our local one. But, you know, there's climate change on the horizon. We need to do something. We need to get the word out. So the more connection on your very local, super local community, or citywide or statewide, the better.
Perfect soundbite. Thanks, Marcus. Well, thank you all. Katie, I'm going to give it back to you to close, Katie and Ashley, to close this out. Thank you all so much.
Thanks so much, Lindsay, and thank you to all of our panelists for putting those amazing videos and presentations together. I know that wasn't an easy process. It was not a short project. So we really appreciate all of the effort that you guys have put in to make today's presentation successful. I hope everyone on the call learned a lot. Again, if you have any questions that you weren't able to get to, we'll follow up with you afterwards, but also in the follow-up email that we'll send before the end of the week, we'll have contact information for all of the presenters here today if you had a question directly for them that you wanted to ask a little bit further, and a recording of the video. So you can watch it again and again and watch all your favorite parts, share it with your friends and family, and really just help spread the word about the possibility of these deep home retrofits. I think that's really why we do education like this, is to show that it can be done, show how it can be done, and to introduce everyone to each other and to experts that can help them along the way and with the process. So, and it's also so great to hear from some homeowners that have taken this project on their own and worked with people to really make this successful. So we are really appreciative to have this webinar in the series to share these personal experiences and like these very projects full of love with everybody as well. Thank you all again for attending. Thank you to our speakers, to our sponsors, especially Brink Building Products for sponsoring today's session. And we hope that you've all learned something that you can take back to your own home or business in the coming weeks and months and year. Apply it in the near future. And if you have questions, definitely reach back out to us and we're happy to help. Coming up in the 2020 GreenBuilt Home Tour Series, it's not over yet. Next Wednesday at 3:30 on June 22nd, we have a Passive House showcase with 3 Passive House certified homes. We also have the High Wellness and High Performance Homes session on July 29th at 3:30 p.m. as well. We'll send an email again before the end of the week with the recording with links to those 2 webinars if you hadn't signed up for them yet, but you'd like to. And again, thank you so much for attending and for participating. Thank you again to our panelists and have a great evening.
Thank you.